All right, so good morning and welcome to this lesson on projectile motion. It is a lesson because actually I'm going to solve a numerical on projectile motion. But before I solve the numerical, I will give you some lessons on important concepts of projectile motion, right? And what are the ways to approach a projectile motion question, right? So through this exercise, my main focus is to build your concept, strengthen your concept logic, explain you why I am doing something like this. A lot of channels and websites you will see have no explanation given, no elaborate effort has been done to teach. It is just a solution, which I can also do, but I will desist from doing any of that. My focus is to make you understand physics. My focus is not to give you solutions. You can find solutions anywhere. What is lacking all over, is explanation. So my channel is dedicated to helping students, 1 million students who want to change their lives in the field of science, technology, and medicine. And physics is very important part of that. So I want to help 1 million students. Please subscribe to my channel and spread this channel in your family, in your circle, so that some students who are underprivileged, who find the subject to be very difficult, they are not able to make careers, are you know able to make a career and prosper through this knowledge of physics which I'm spreading. So thank you very much. If you can spread my channel, subscribe to it, it will be a great favor to this whole country itself. Let me come to this question, and the first thing always is to we read the question. So there is a hill which is 500 meters. Supplies are to be sent across the hill using a cannon. Okay, that can be hurl, that can hurl back. Cannon is like a some sort of mechanism by which you can throw and at a speed of over the hill. And then the canal is located at 800 meters from the foot of the hill and can be moved on the ground with the speed of 2 meters, so that the distance from the hill can be adjusted. What is the shortest time in which a packet can reach across the hill? So let me just draw the situation. This is your hill. This is your ground. Maybe your cannon is lying here. The cannon is throwing the supplies. Okay, supplies could be food, it can be water, and you're throwing this, and this is 500 meters, right? So 500 meters, maybe some soldiers are sitting here, and the soldiers need supplies, and someone from here continuously throws the supplies so that they can be caught here, right? So you can catch the supplies here, and the uh, the cannon can throw it at a speed of 125 meters. Obviously the cannon will not fire horizontally. The cannon has to fire at some angle, so I will write this as 125 meter per second, and it is going in a projectile motion, and so the question is from projectile motion. It's an NCERT exemplar, and the cannon is 800 meters. So this is 800 meters, right? All right. The other good part is that the cannon can be moved at a distance, okay, with a speed of 2 meter per second, right? So you're allowed to move this cannon, with some speed. Question is, what is the shortest time in which the packet can reach on the ground across the hill? You can move the cannon, and what you want to find is the shortest time. Your aim is to find how much minimum time you can take, the shortest time possible, because you want the supply to reach ASAP, right? So this supply should reach this point. This is the point which the supplies are required. This is the point at which supplies are available and are projected. Okay, and gravity is to be taken as 10 meter per second. Okay, now what is the meaning of the word shortest time? This is something we need to really think about. And also, the cannon should be able to move at a speed of 2 meter per second max. All right, so let's try and understand the situation. See, I hope you have understood that this cannon can move. It is you're allowed to move this canon. I'll just bring up a pen. I think it will be okay. Let me use this. So you're allowed to move this canon. This canon can move. Now, the trick in this question is, what is the meaning of the word shortest time, right? Because you want the supplies, the supplies to go and reach the soldiers, for example, ASAP, right? So you want this to be done in a very fast manner. This is the most important part of it. I'll just add something to this, okay? So let me give you some concepts, okay, which will help you solve some of the problems. Let's say you have a situation like this. This is a hill, and and you want to throw something which is which reaches the top of the hill, right, from the bottom. The fastest way to throw this, and you want elevation, which is, for example, you have a high jump player, right? A high jump player. What does a high jump player do? Okay, they come, they come, they run, and when they jump, they just cross the high jump and they move to the other side, right? So this is a high jump player who jumps from the mattress and goes like this. And if you see the trajectory of a high jump player, he just touches the highest point, which is the pole, for example, crosses it over and goes. High jump player, wants that his vertical velocity, right, is adjusted in a manner that he is able to just cross over this, okay, just cross over this. But if you consider a player who's into long jump, right, who's into long jump. Now, what is a long jump player? A long jump player wants to cover maximum horizontal distance. The high jump player wants to do a vertical, trajectory, go up as high as possible, but also he the the long jump is what we have covered, right? But if you talk about somebody who does a long jump, something like this, what they want is to go the longest horizontally. So when these guys, leave the ground, their emphasis is not height, but horizontal. So what they do is they want to keep their horizontal velocity very high. So they want the horizontal velocity to be the highest, right? So they want the horizontal velocity to be the highest, whereas a high jump player, wants the vertical velocity to be highest. But if you make your vertical velocities to be very high, what will happen is your time of flight above the pole will go up, right? So you will stay in air for very, very long. You don't want a high jump player doesn't want to go up so high that he stays in air for very long amount of time. A high jump player wants to just clear this and come back, right? So which means the high jump player wants to complete the motion in a very fast time, yet cross the pole, right? This is the pole. So what does he do? What he does is he adjusts his vertical velocity, which is his focus. A high jump player is not worried about horizontal velocity, right? So ux is not his concern. His concern is uy. And within uy, he wants to do it in a manner so that his time of flight is minimized and he just covers the pole, right? So he doesn't want to go here, right? Because he just needs to cover this height. Why should I, waste his time covering this height, right? So if you think about this, our situation, the supply should also just cross just reach here. Why should supply go like this, right? Why should supply go like this? Why should you have a very long time of flight, right? Why should you waste your time? This is time wasting, right? This is complete time wasting. Your time of flight increases with this, although you reach the same place. But if you go like this, the way this gentleman who's a high jump player. This is so the point I'm trying to drive home for a shortest time period, which is a catch. If you understand this concept, the shortest time, you will be able to solve this problem. For shortest time, you should behave like a high jump player who just clears the pole. So similarly, you also should throw this supply, right, in such a way that you're just about able to clear this. So your supply should go like this, and then this should become the highest point for your supply. So the motion should look like this, right? So you're just able to cross, and then it becomes, you reach the other side. So it's a like a symmetrical projectile motion. This is the highest point of the projectile motion. And similarly for this gentleman, this is the half the distance, the balance half distance will be there, because this is the highest point, and it will follow the law of symmetry, right? So you must understand the meaning of the shortest time. So I hope you got two new concepts. The high jumper who has to clear takes the minimum time by just clearing this point. The long jumper is always worried about the horizontal velocity, wants to maximize the range, and his focus is obviously horizontal velocity. And we know how he can, use the angle which is 45-degree also to maximize the range. But remember, the emphasis is not, the time. The emphasis is range. In a long jump, the emphasis is not time. But in this situation where we discussed a high jumper, the emphasis is just clear this, right? Just clear this, which is very similar to this. And why should you waste your time, unnecessarily? This is not required. Waste your time. So the logical conclusion for a shortest time is that you should project your body in such a manner that you're just about able to just about clearing the highest point, which means you are actually talking about the so let me say just about clearing the hill in this case in our question. So this is the highest, this is your hill, right? This is the hill. With this in your mind, let's now worry about how this question is to be. I will redraw the situation, and then we will talk about what is the significance of canon and stuff like that. Let me just redraw this. This is your the hill. This is your canon, right? This is your canon, and you are going to throw something, and it should be thrown in a manner that it just about crosses, because you don't want to waste your time in extra flight, right? You don't want this to go anywhere else. You just want, so the minimum flight time will be when it just about clears that, which is this is going to be, I think this is given to be a height of 800 meters, right? It's a 500-meter hill, which you need to clear. So let me put it this as 500-meter, right? And what is the velocity, which is the with 125 meters? So wherever you are, this is 125 meter, right? So let's divide this into two parts, and the highest point you will reach, which means the velocity, the vertical velocity here will be 0. Here the initial velocity with which you are throwing this is also, let's say the angle is not given to you in the question, right? There is no angle which is mentioned. We will find that angle with which it has to be thrown. So let this angle be theta, and this is theta. So this is u sine theta, right, which is the horizontal vertical part of the initial velocity, and the final velocity. So let's say v v is equal to u minus gt 0. So I'm writing the y-axis part of it. U is 125 sine theta minus 10 into t, and 125 sine theta is equal to 10t. 5 25s are 5 2s are 25 sine theta is equal to 2t, right? So this is equation number 1, which you have the first equation. And then what you want is, since the velocity here is you know the highest point attained, so you know the vertical distance also covered. So I will write S is equal to ut minus half gt squared. This is again, I'm worried about y-axis part of it. This is 500 is equal to 125 sine theta multiplied by t minus half into 10 into t square. So 500 is equal to 125 sine theta t minus 5t square, right? And then you know what is a value of 25 sine theta. You can always substitute here, right? 25 sine theta is 2t. So 500 is equal to, so I'm just putting 25t is 2t, and then we are left with so you 25 sine theta has gone 5t, so this is 5t is what is left out of that minus 5t square. So 500 is equal to 10t square minus 5t square. 500 is equal to 5t square, and t square is equal to 100, and t is equal to 10 seconds, right? So now you know that this particular situation, which we just covered, this takes 10 seconds, right, for this body to reach. And let's calculate, this particular part, which is a horizontal distance covered. So if we know 10, let's calculate the angle first before we cover this particular horizontal range. It is, I'm writing the x-axis now. So the range is given by the horizontal velocity, which is 125 cos theta multiplied by t is equal to, so I know my t 125, when I'm calculating half, so my, this is r, when I say this is r, okay, this, the total is r plus r. I'm just concentrating on this part. R is equal to, so this is actually half the range. I will just write half the range into 10, which is half the time, into cos theta. And if I know sine theta is equal to 2 into 10, I'm substituting here, divided by 25. So sine theta is equal to 4 by 5, right? So you have a situation like this. This is 4 by 5. So this is 3. So this range 125 into 10 into 3 by 5. 5 twos are. So 125 multiplied by 6. And this is 750. So this should be 750 meters, right? For, so if you projected from the the hill, this is your hill, at a distance of 750 meters, it just crosses this. Again, you don't want to waste extra time in flight. You want this to reach fast. People cannot wait for supplies to reach and come easily traveling in the air. What they want is the fastest way. The fastest way, I told you, is when it just grazes past the hill. Obviously people will catch it here, they will catch the supply here. But remember the example of the high jumper I gave you. The high jumper also behaves in this manner. He adjusts his time of flight in a way that he is able to just about clear this. And we are using the same methodology used by a long high jumper to solve this problem. So that concept as to how a high jumper and a long jumper behave should stay in your mind forever, while you're solving and understanding the shortest time concept and the impact it has on solving the problems and adjusting. But remember, this particular canon was not at a distance of, it is at is, let me just redraw this now. Now that you've understood that canon should be at 750 meters, let's say, let me just give you an insight on this one, right? So if I give you an insight on this one, the canon is should be at a distance of 750 meters. But remember, the cannon actually was at 800 meters, right? 800 meters. Now, the cannon has a speed of 2 meter per second, 2 meter per second. It has to therefore cover a distance of 50 meters to be, able to reach here. So cannon will take, with that speed, 50 divided by 2 is equal to 25 seconds. The cannon will take 25 seconds to cover this. So first thing, the soldiers or whosoever is using this cannon, if it has a wheel, for example, they should push the cannon. It should cover 50 meters, then it should reach here, and then once it is at 750 meters, you should immediately press your triggers and then start this. And this time of flight which we have just calculated here, for this body to just reach, the time we calculated, t came out to be 10 seconds, right? It takes you 10 seconds to reach the highest point of the hill. So there are two parts to the motion. So one is the cannon should first be pushed like this. The cannon should be pushed like this for 25 seconds. Then you press it, and then it takes another 10 seconds, which is the shortest 10 seconds here. But 25 seconds are like, mandatory. You can't, if you, the biggest mistake you will do is if you start firing it from this place, then it becomes very difficult for you to understand what exactly is to be done. Although the significance of, I think, 2 meter per second gets lost. Since it was a moving uh, situation, this cannon is moving. It would have been rather difficult for you to solve this. So you have two times. One is the time of flight, which is this 10 seconds, and then you have extra time getting wasted, where the cannon has to move through a distance of 25 is equal to 35 seconds. 35 seconds is the total time which this particular material will take to reach the highest point, right? So if you have packets, which you want to throw at the highest level, don't blindly start throwing them from a distance of 800 meters. Throw them at a distance of 750 meters. Also understand this particular time. The catch word in this whole question is shortest time. I think rest is calculation, but if you understand the shortest time, meaning that you just need this to pass through this, I think you will be able to solve this very easily and get the answers. I hope this made sense to you. I have numerous videos on projectile which I have solved. These are solved numericals with complete explanations. This is the only channel, I'm again repeating, which gives you a good explanation of the concepts. It is just not a channel which is giving you just solutions. Complete explanations are given with the help of concepts. I hope you like this high jump example, and it does add some value in your mind as to how the projectile motion is used in practical life and what type of velocities matter. If you use too much of vertical velocity, your time of flight goes up, right? If you throw a ball upwards with a high velocity, it will stay in the air for very long period of time. You don't want the ball to stay in the air for very long period of time. You just want that the ball should reach the highest point of the hill, and that's all. You adjust your vertical velocity accordingly. In our case, the velocity is given. The only thing you could do was adjust the angle, and that angle results in the vertical velocity, which is not an excessive velocity. It is just an optimal velocity so that it is able to cross the hill in the minimum possible time period. So I hope you get it. The more is the vertical velocity, the more time of flight results. You don't want that to happen. I'm just summarizing this for your benefit. This concept should stay with you forever. Go through my playlist of projectile motion. It will really help you get a very good grasp on projectile motion. That's my promise to you. All right, so just let me conclude this numerical. I think what we did was we calculated this particular part, that the cannon has to be moved from one place to another. That takes you 20 seconds. And then this particular time of flight, which is just the minimum shortest time because you're just about touching this, is another 10 seconds, right? This is another 10 seconds. But the question is, when will it reach the other side of the hill? So remember, there is a concept of principle of symmetry in projectile. So if you go and watch my videos and search for principle of symmetry in projectile. It is one of the most important concept you must understand. And let me show you how to apply the principle of symmetry for balance. So this was 20 seconds. Now by symmetry, the other side when this falls also takes you 10 seconds, right? 10 seconds. So the total time the in a package will take to reach the ground is 20 seconds on the canon, then first 10 seconds and then another 10 seconds is equal to 40 seconds, right? So this is the conclusion. But remember, these two sides of the motion are completely symmetrical in nature. I have deliberately kept this, a little delayed in my solution because I want to emphasize that you must understand the principle of symmetry, which gets applied in a projectile motion very often in many situations. This was one of the situations. So go through all my videos. Please do learn principle of symmetry. I hope this made sense. Let's continue with our discussion on this question, but this completes the question. I think this is uh, 10 seconds, 20. So I think this was 25 seconds. So let me just correct it. So this is 25 plus 25 and 45. So don't worry about this, but I think the main point I'm trying to emphasize is the principle of symmetry is very important for you to understand. If you don't learn the principle of symmetry, you will find the projectile questions as they become more complex to be very difficult. So as you're progressing, increase your order of thinking and also learn about principle of symmetry. Thank you very much for my next video, and I hope that you enjoyed this video thoroughly. If you like this, like it, subscribe to my channel, put your comments if you're not able to solve a problem. Again, I request you to put your comments in the comment section, and you can also write some questions you're not able to solve, which I'll try and solve for you. Thank you very much.